In this video, I'm going to talk about the three types of radiation most commonly addressed in a high school chemistry class, and those are alpha, beta, and gamma, although we also have positron and neutron emission and other things that we also often talk about. But these three particles, or these three types of radiation, are the most commonly discussed. And so we're going to start with alpha. Alpha is, they're named after Greek letters, so alpha, beta, gamma. Alpha, the symbol for the Greek letter alpha is this sort of funky looking A or weird looking fish. And it's made of 2 protons and 2 neutrons. So our alpha particle is going to have a mass of 4 atomic mass units, because each proton weighs 1 and each neutron weighs 1, so altogether it's a mass of 4. When we look at beta, the symbol, the Greek letter beta, looks like a B with a little stem on it, and it is the same composition as an electron. Therefore, it has a charge of -1, but a mass of 0. You may be wondering, well, if this radiation is coming out of the nucleus of an atom, that's what radiation is. We have the nucleus of an atom. We're not looking at the electrons around the outside. And what happens is it's unstable. And generally this has to do with the number of neutrons that it has, because neutrons are like the stabilizers in a nucleus. Protons are positively charged, so they don't want to be next to each other. So neutrons serve as our spacers. And our alpha and beta radiation is a particle emission. The alpha would be 2 protons and 2 neutrons in a packet, all 4 coming out together as a particle. Beta is also particle emission, but it's an electron that's shooting out of the nucleus. Now you might think that's kind of weird, because we've always been taught that a nucleus has protons and neutrons and does not have any electrons in there. However, a neutron is just a little tiny bit heavier than a proton. And so what happens is a neutron, which is neutral, is basically a proton and an electron stuck together. When the nucleus gets out of control, unstable, it can shoot out a piece of that neutron. It can shoot out the electron part and keep the proton part. And we'll talk more about that when we talk about equations in the next video. So both alpha and beta are particle emissions. Alpha is 2 protons plus 2 neutrons, and beta is an electron. Our third type, gamma, is sort of a weird looking Y with a loop on the bottom, or a fish doing a nosedive. That's the symbol for gamma. Gamma is just energy. It has no charge and it has no mass. So gamma radiation is our top one here, which is just pure energy that shoots out like a bolt of energy and lowers the amount of energy in the nucleus to a more stable state. So when a nucleus is unstable, that's when it's radioactive. When it shoots off its particle or energy or both, then it becomes more stable. If it's still unstable, it may give off another kind of radiation. And it may continue this until it finally reaches a stable form. Because the radiation type can have different charges, if we emit those radiations from some type of radioactive substance and we shoot it through negative positively charged sides or plates on the 2 sides, then alpha is our green line, and alpha, it has a positive charge because of those 2 protons in it. So it's going to be attracted to the negative plate and repelled by the positive. So it's going to curve and hit our collection plate closer to the negative side. Gamma, which is red, has no charge. Gamma is just pure energy, so it's going to shoot straight out. It's not going to be affected by the plates, and it's going to hit dead center. And then our beta, which is our blue line, when it shoots out, it's going to curve toward the positive plate because it's an electron. And it's actually going to curve more because it has less mass than our alpha would. So a better diagram would have this curved like this, and maybe our green one curved less. Because our particles have different masses and different speeds that they're traveling, they're going to have different amounts of protection needed to actually stop them. So alpha, being a large particle with 2 protons and 2 neutrons, is moving slow compared to the other types, and it can actually be just stopped by paper, like a notebook or a few sheets of paper. So when you see these people on TV or movies and they're walking around in those white paper suits, the only thing that's really protecting them from is the alpha radiation, because that will be stopped by paper. Beta radiation is just an electron. It's much smaller and it's moving way faster. It will penetrate, go through the paper, and you need a sheet of metal or a thick piece of wood to stop the beta particle, because it is still a particle, so you can stop it, but it is moving way faster than the alpha, so it has more of a penetrating ability. Gamma is just pure energy. It has no particle nature to it, therefore it's much harder to stop. It will go right through paper, right through aluminum, and lead, being very, very dense, will stop most of it, but some of it may even get through the lead unless it's a terrifically thick piece of lead. So when we have nuclear power plants with all the shielding around the core, all that shielding is to stop our gamma particles. Because if our radiation was only alpha and beta, we wouldn't need nearly the shielding that we need if it's gamma. Because of this, if your body is exposed to these different types of radiation, alpha has a hard time even getting through your skin. You pretty much have to eat or drink something contaminated to get the alpha inside your body, and then if it decays or gives off its radiation inside your body and hits some live cells, it can cause some damage because it has that +2 charge on it. So if your DNA happens to be replicating right as this particle hits the cell and penetrates into the cell, it can mess up and cause mutations in your DNA. And unfortunately, the part of humans' DNA that keeps us from getting cancer, that tells our cells when to stop dividing, is particularly vulnerable to radiation. The next type, beta, is harder to stop. It went right through paper and it took a sheet of metal to stop it. So it will penetrate from outside of your body. It can pass through your skin into your body. But since it only has half the charge, alpha was a +2, beta's a -1. Since it only has half of the charge, 1 instead of 2, it only causes a little bit of damage if it gets in your body. So it'll go through your body and hit more cells, but the damage it does to each cell is actually less. Gamma is like a high energy X-ray. So if you've had an X-ray, you know that you can't even feel it, but if you get exposed to enough X-rays, that can be bad for your body because it's a form of radiation. Gamma is like a high level form of radiation, and so if you're exposed to this, it can actually kill your cells and cause radiation sickness. They actually use this in some cancer treatments when people have to have radiation of a tumor or something. If it can't be removed surgically, then they will actually pinpoint this to exactly the spot that they need it, not your whole body. So a quick summary: alpha, 2 protons and 2 neutrons. Therefore, its symbol is He, because helium has 2 protons. Helium's right there, 2 protons. And so this is just like a helium nucleus. It has 2 protons, but its mass is 4 because it has 2 protons and 2 neutrons. So the charge is 2, but the mass is 4. It has a positive 2 charge like an ion because remember, there's no electrons associated with this. It came out of the nucleus and it's just shooting super fast, and electrons don't attach to that. So it's just like a helium nucleus with a +2 charge. 2 protons, 2 neutrons, charge is positive 2. Relatively heavy compared to our other types of radiation. 8,000 times more massive than our beta, which is just an electron. It's about 10% the speed of light is its speed. Its penetrating ability is low. It just goes a little distance in air and only 0.04 millimeters in human tissue. And the ability to ionize atoms, to turn atoms into ions, is very high because of that positive 2 charge. When it slows down, it can pull electrons off of other things and make them into ions. Beta comes in 2 flavors, beta minus and beta plus. Beta plus is also called positron. So beta plus or beta positive is 0, positive 1, and Re for electron. I know up here it shows a beta particle, but that's not generally the way that we show those. And our negative, our beta negative would be, or beta minus, would be 0, -1 E because it's an electron. Beta plus is the same as positron emission. If you just see beta, assume it's beta minus because positron emission is much more rare, and it will tell you, the problem will tell you if it's beta positive or beta plus. If it just says beta, assume it's beta negative. Remember, these are electrons, -1 charge, very light, about 90% the speed of light because they're very small, so they're moving way faster. They have a medium penetrating ability. They go a lot farther in air, a lot farther in human tissue, and because they have a -1 charge, they are able to attach themselves as like an electron to an atom. Once they've been slowed enough, then they can attach to an ion and neutralize it, or if it's a +1 ion, they can make it into just a regular atom. Gamma is just energy. So gamma doesn't have any numbers on the left side. You just show it as the gamma symbol. It's an electromagnetic wave of energy. It has no mass. It's traveling at the speed of light, which is 3 × 10⁸ meters per second. It goes far in air, it goes far in water, and it goes straight through us. But because it has no charge and no particles, it has a very low ability to cause ions because it doesn't have a charge to do that. I hope this has helped. We will talk about nuclear equations in the next video. Check the description for links to that video and others that may help you in your chemistry course. I hope this has helped. Have a great day.